yours. I look forward to hear your talk.
Thank you. Thank you very much. Thank you for inviting me to share some thoughts with you this morning. And it's always nice to be present with all these experts in the field of circular building and people thinking about the new steps, next steps, and how do we move towards a new generation of buildings that will answer some burning questions, societal questions we have today and are facing all on this planet. Yes, thank you for introduction. And indeed, I've been working on this issue and being challenged by the questions of how to move further with the design and construction of our buildings and built environment. And I started work on my PhD actually a long time ago, more than 20 years ago. So it's a kind of long history of me dealing with this subject. And obviously in the meantime, much has happened and my interest was never disappeared, obviously, because that PhD, which dealt with transformable buildings and design for disassembling construction, which has been seen as kind of pioneering at that time, more than 25 years ago, when no one was talking about disassembly in buildings, is now burning question, and there are more and more people in construction industry interested in these concepts. So through all this work, obviously, as being a scientist and developing tools and protocols to design new systems and buildings and help measure the performance of these new buildings, which we call circular now, I did indeed manage to also test some of these cases on the real developments and working with construction industry, trying to showcase how the new generation of buildings and products might look like. So my presentation will be kind of combination of both. And obviously I would like to start with presenting this new concept of what we are seeing as circular building, and I call them reversible buildings. Obviously, as my statement on how do I see a new generation of buildings that will answer the requirements of circularity. And the reason why we need the new approach is the fact that the buildings which we still design and build are built for one-use life cycle. We bring materials into buildings. All these materials have different technical life cycles and different use life cycles because the materials have different purposes in the buildings. And yet we put them together and optimize methods of construction around initial use of the building. We think buildings will stay there forever. We design them as static structures, meaning that every addition or change will result into demolition. As an opposite to that, this in order to design buildings that will be adaptable and enable extension of use life of buildings and materials, and high-level recovery loops of materials after initial use. Reversible buildings would bring kind of shift and paradigm shift and shift in the perception on buildings and change from seeing buildings as static structures towards seeing buildings as dynamic structures, which are adaptable to different use options and user needs, but also their systems and products are reconfigurable and reusable. So a reversible building is seen as a building which has, on one hand side, high transformation capacity on a building level, so it's adaptable to different user requirements. And on the other hand side, it has high reuse potential of its materials. That means that materials can be recovered for a new use in a new life cycle. That brings me to another point that reversible buildings are addressing, and that is what I see as a fundamental mistake or error that we bring in designing and still have in designing buildings and built environment. Because architecture is there. The first purpose of architecture in building is to provide the comfort and shelter to human activities. And these human activities, as we know, are quite dynamic and are changing quite on a regular basis. So something which is very dynamic and changing all the time, and we see that the pace of change is accelerating ever more. We managed to place into fixed structures for which we believe that will stay there forever. So there is this big contradiction in what the purpose of building is to accommodate and provide comfortable living of human beings on the planet, and then bringing around this living, which is this dynamic fixed structure, which obviously means that every time, and this is an example I've often used to show what it means even in our lives, not thinking about other aspects of living as working, mobility and so forth, but even just in our lives, we go through a number of life phases, and every life phase will require something else from our built environment. That means we need to change our houses and built environment like every 7 or 10 years. At the moment, what we do in the Netherlands, as buildings are not designed for adaptability, they just move every 7 on regular basis. In statistics, they would say we move every 7 years to another house, as the original one is not adaptable. So the key question that the new concepts of circular buildings and reversible buildings are addressing is the issue that the human life is very dynamic, has very dynamic processes in its very general form, and that architecture and building, in order to become sustainable and to enable the circularity and efficient use of resources that will support human life, needs to follow these dynamics as a logical follow-up step. And to move away from this approach, and this is what we see even today on our street. This is center of Amsterdam, 2014, and Fortis Bank, which was designed in 1998. It's like after 16 years, a building has lost totally its value on a city level. It was placed in a city center. On the structural level, the material level, this facade is a granite, which can be there. If you go to Cheops pyramid in Egypt, you will still find the same granite in a pyramid, but this one has been ended in these small pieces, which you see here. In 16 years, we managed to crash it to pieces and totally destroy it. So that's our approach, which requires this new generation of building, a new perception of how we perceive buildings and their performance for humanity. And that brings us also to this huge challenge that we face today, and that is the effective use of resources for human activities, and housing and construction cities play a very important part in supporting human life on the planet. So these charts I am showing here are the charts of the World Bank, which they produce the charts illustrating the level of use of resources per country by calculating global footprint per country. And the green countries, which you would see, like the first map is made in 1961, when we had most of the countries with lots of environmental capital being used to produce goods and services needed for population in that country to support their life. When the country becomes red, purple or red, that means that these countries use more resources, need more resources to support their life than they have at disposal. And in the map of 2016, we see that actually all built environment and what we have on the planet, that almost half of the countries on the planet use more resources to support their everyday life than they have at disposal. And basically, it's on average 4 times more than resources than they have within their own borders. That means they import from other countries, and that means that other green ones become less green and become more red again. So in the end,